So now let's look at some basic algebra problem. We have three people. We are trying to find the age of one, but we do not know any of their ages. We just know their ages in relationship to one another. So what we're going to do is we're going to use algebra to set up an equation in order to isolate a variable and find the age of the variable. From there, we'll be able to replug this back into the problem and find the answer. We reduce the expression and we get an age of 5 for Peter. Now we'll take a look at a geometry problem. So we have a pool that's been tilted due to an earthquake. The water is shifted into a prism shape. We don't know the original depth of the water. What we do know is the current volume of the water, and that none of it has been spilled. So what we're going to do is find the area, or find the volume more like, of the prism, and relate that back to the volume equation for a parallel box, and then we're going to solve for the unknown. Here's a picture of what we're looking at. And there we have our solution, 2.625 meters. And lastly, we're going to look at a problem for calculus. Calculus is used to find relationships between changing variables. It's also used to find the area under curves and the slopes of curving lines. It has thousands, if not more, applications, and a very useful subject, typically seen in college or advanced high school. So we see what we're doing here is called differentiation. We're differentiating the two equations in order to find where they intersect and to discover where the area is maximized. And we find that the shortest side possible is 32 meters.